Thank you for coming to my talk. This is Building Native Extensions. This is my first live in-person talk in 8 years, so please be gentle with me. Okay. If you don't know me, I am Mike. I go by Flavor Jones on the internet. I work at Shopify, where I help lead the Ruby and Rails infrastructure group, and I maintain Nokigiri, among other Ruby gems. At RubyConf a month or so ago, I presented a technical talk on this topic, and it was about the how of native C extensions. For that talk and for this one, I prepared working code to demonstrate what a C extension is and show a few different ways that C extensions can be packaged and installed as a Ruby gem. That code is available for you to read and steal from, MIT licensed. Here's the bit.ly link, and if you like typing, there is the GitHub project name. My hope in presenting all of this how-to material is to clearly show a few basic patterns for C extensions. There's not a lot new here. These patterns have existed for years, but to my knowledge, this is the first time they've been named and all presented together for comparison and contrast. Now, what the RubyConf talk was missing was the why. That explained why Nokigiri evolved to use more and more complex techniques for compilation and installation over the years. And so this talk is going to get through the how-to section as quickly as I can so that I can talk a little bit more about the why. So in that sense, it's kind of a companion talk to the RubyConf. So a little bit of repeated material, but not too much. So the things I will talk about today. The first half is going to be about Ruby C extensions. Then I'm going to spend some time talking about why you shouldn't do this. And then I'll talk about why it was a great thing that I did this. I'm going to talk to you a little bit about trust and security. I'm going to try to scare you a little bit. Ooh. And if we have time, we'll do a Q&A, but I got a lot of slides, so that might not happen. And I apologize in advance. What is a C extension? No big deal. It's just Ruby code, but you write it in C. We create new extensions every day in Ruby simply by writing Ruby code. Right? I can extend the Ruby virtual machine to have a new module named Mike is Great, simply by doing this, right? I've extended the virtual machine, not so hard. A C extension is the same thing, except you write the code in C instead of Ruby. So here's the same extension written in C. It's a little more complicated, but it's not too bad. And you can imagine analogous C code for any Ruby statement that you might write. MRI can't read that C code directly, though. We have to first get it into a form where it can be required like any other Ruby file. This is where it can get challenging. We have to first compile the C code into an object file and then go through a process known as linking, with scare quotes, to combine it with Ruby's C library. Only then is it in the correct form to be required, which is what we call a shared object. Okay. Lucky for you, I have some working code handy to actually demonstrate all of this. The gem I'm going to show you is called Isolated because it is completely self-contained and doesn't call any third-party library. So this is just to get a basic foundational sense of what goes into a C extension. So you might choose to write a C extension like this that's isolated and self-contained as a performance optimization. If you have like CPU-intensive work to do, bcrypt is a really great example of this. It's iterating over cryptographic math, which is just faster in C than it would be in Ruby. Although, side note, with the advent of better and better just-in-time compilers, that might not be true for much longer, so like benchmark before you make that decision. So the isolated gem contains a little bit of C code to perform that CPU-intensive work. Here I've listed it as a to-do, like any good developer. And this is just like the Mike is Great example, but it has a singleton method defined, which is called do something. Because it's a small extension, it compiles and installs really quickly, under a second usually. And when we peek at the directory where the gem has been installed, we see a file named isolated.so. That is the C extension. That's the compiled C code. And it can be required like any other Ruby file, just like this. We do a require relative, and that loads that shared object file. So there's a lot going on. We'll go through it slowly one more time. Isolated code is checked out locally. The gem spec file tells us where in the file structure, the directory structure, we can actually find the extension directory. That extension directory contains all of the C code, as well as the extension configuration file, which is conventionally named extconf.rb. And that extconf is a Ruby script that has one job, which is to write a precise recipe for compiling and linking the extension. In the case of isolated, the isolated gem, this extconf file is as simple as it gets. MKMF is short for make makefile. That's a Ruby module that ships with the standard library. It defines create makefile as well as a handful of other methods for advanced configuration. And the create makefile method is actually what writes the recipe for compiling and linking. Now, because we haven't configured anything else, it's going to adopt some intelligent defaults. And the recipe that it spits out is going to start out looking something like this. So this line reads, please compile isolated.c into the object file isolated.o and make sure to include Ruby's header files. And if we had more C files, each one would be compiled separately into a separate object file. The recipe will contain a second step, though, too, which is the linking step. And that combines all of the object files with Ruby's C libraries to create that shared object. And this reads, please create a shared object by combining all of our object files with Ruby's library and the system's C and math libraries. When we actually run this, we get a makefile that gets created. And we can look at that makefile. And it is big, and it is long, and it is ugly, but it is very precise. Create makefile has done a lot of work for us, and it's turned that generic high-level description into something that's specific for my CPU architecture, Linux x86, 64, and for Ruby 3.0, right? So the Extconf is generic, but the makefile will only work on Linux x86, 64 running on Ruby 3.0. So now finally, at the end of the journey, if I actually run make, I generate this isolated.so file, which we can look at. We can see that it is a shared object, and we can even see, if I type fast enough, that we can require it like any other file, and we can call methods on the classes that get loaded. Great, success, end to end. If you actually run gem install, you'll see it get installed. It installs under a second. Everything works perfectly. Summary and diagram form of what just happened. You run gem install, it downloads the gem file from rubygems.org. It extracts the gem spec. It looks at the gem spec to figure out where the extconf file is. It runs that script to generate a makefile that will then compile and link into your shared object. It's just that easy. Okay. There's a lot that can go wrong because that's a very complicated series of steps. So the first thing, the most common thing that goes wrong is people don't have a compiler toolchain installed. And by this, I mean you need to have make, you need to have a compiler, a linker, you need the system header files, and you need the system libraries. All need to be installed in the right place and be discoverable. Setting that up is such a common problem that Nokigiri actually has a separate subsection in this documentation for getting that installed. A lot of Linux distros will offer a meta package like Build Essentials to help you do that. On Windows, Ruby is very lucky to have Lars Canis and before him, Louis Levina, maintaining the Ruby installer dev kit. It ships a version of Ruby along with the entire integrated toolchain for Windows. It's awesome. On Mac OS, you've got like Xcode command line tools, which have their own installation problems. I use Linux. So second, you'll need to have a working Ruby development environment, which are Ruby's headers and libraries. And this can be a real hurdle for Ruby newbies. So I'm sure you've all seen this error message at some point in time. A little hard to understand, and you need to actually install the Ruby library. Install the Ruby libraries. Third, you need a consistent environment. So once you build that shared object, your C extension can only run on like that architecture with that minor version of Ruby with those system libraries. You can't copy your gems from your Mac to your Linux production machine. You can't upgrade Ruby and still use the gems that were previously installed. Like there are limitations. So those things also go wrong with these C extensions. But C extensions solve a lot of really good problems too. So I mentioned earlier, performance optimizations like bcrypt are a great opportunity to use a C extension. But there's another more common reason, which is to integrate with a third-party library. And the reason I'm giving this presentation is because I've spent a lot of time over the last few years working with third-party libraries and calling them from Ruby. I've been the primary maintainer of Nokigiri for a decade. If you're not familiar, Nokigiri is a Ruby library for parsing and manipulating XML and HTML. Super boring. The formal specifications for XML and HTML are huge. It would be a monumental task to try to re-implement all of this in Ruby from scratch. And if you don't know this about me, I'll tell you, I'm pretty lazy. So instead, Nokigiri uses existing open source libraries, libxml and libxslt, and interacts with them through the C extension. A lot of Ruby gems do this. Here's a list. You can probably think of one or two others. And most of these gems are just a thin-ish layer of Ruby and C. that work together to make the library's features available as idiomatic Ruby. There are other ways to call third-party libraries, though. In Ruby, there are a dozen ways to do everything, and this is no exception. One popular method is Ruby's foreign function interface, or FFI. This allows you to call for Ruby code to call C libraries directly without having to write any C code. It's a really powerful tool, but choosing when to use it is a topic for another talk, so I'm not going to dig into it today. If you're on JRuby, you could write an analogous Java extension that works very similarly. Again, that's a topic for another talk, but it's worth noting that this is how Nokigiri works on JRuby. We have a Java extension. Finally, let's get to actually accessing an external library. For the next few minutes, I'm going to show you a series of gems that escalate in complexity, and they each build on the previous one, so we'll get there pretty quickly, but we'll get there in small steps. So again, all the code I'm presenting here is in a GitHub project. That's the bit.ly link, and that's the long form if you care. So strategy number one, gems like SQLite 3 and RMagic follow this strategy, which is that they require the library to already be installed on the system by the user before you install the gem. That's why it's called the system strategy. It has to be on the system already. So I've created a gem to demonstrate how to do this. All these examples are going to use libyaml. If we look at the C code for our system gem, you can see we're calling the function YAML get version, and we're returning the result in a string. It's a really simple integration, but it proves that it works end to end, and this is what we'll be doing over and over again. Looking at the Extconf, it's very similar to the isolated gem, except it has a new stanza where we call find header and find library, which do exactly what you think. They go out into the system and try to find where libyaml might already be installed on the system. If it finds them, it makes sure that the compile and link steps pull in the header and the library. So then the recipe it spits out will have the libyaml include directory in the compile step and the library directory in the link phase. Like, it's pretty straightforward. So let's actually go ahead and try to build this. Okay, my bad, I don't have libyaml installed. I'm sure this has happened to you all too. So let's imagine I spend 5 minutes Googling to figure out how to install libyaml on my system, and we'll try that again. So this time I run extconf, it generates the make file. I can run make, it generates the shared object file. And I can even see that it is calling out to libyaml somewhere on my system. So this shows that as long as libyaml is on the system and is discoverable, then we can compile a link against it. Great. Great success. If you actually go and run gem install RCEE system, you'll see it installs, and it's a little bit slower than the isolated gem because it's actually doing more work. It's still pretty fast. It's about 1.5 seconds, not too bad. There are things that break when you're using the system strategy, though, which probably are obvious. One is the user has to go figure out how to install that library, like we just saw. I had to go through that process. Another one is where on the system is that? It could be in a non-standard directory somewhere. It could be an old version, or it could be a version that's too new for the gem to understand what to do with it. And it could be like a compile time feature or flag is not set. So maybe as a gem maintainer, you're okay with all of these trade-offs. In that case, what you do is you improve your documentation to explain how to install everything. You have to add edge cases to your Extconf for non-standard directories. And you have to add edge cases to your code to handle feature flags being flipped on and off. This can get really challenging in the real world. If you take a look at the Extconf for SQLite 3 or RMagic, you can see exactly how messy this gets. RMagic has like 15 years of installation directory hell all coded up in the Extconf. It's a good time. So Nokigiri relied on the system strategy for about 5 years, up until 2013. And this is the bug that broke all of our assumptions. libxml 2.9 had a nasty bug in XPath that broke everybody's CSS queries. And Homebrew immediately upgraded the entire universe to using this buggy version of XPath and libxml. So the fix to accommodate those versions would have been a little messy, and the alternative was to include a known good version of libxml inside Nokigiri, which brings us to the next strategy, which is to package up libraries with the gem. The easiest way to package up external libraries is to just drop source files into the extension. I'm not going to go very far into that explanation today. If you're interested, please check out my RubyConf talk or check out the GitHub repo. Instead, I'm going to focus on packaging a tarball, an upstream tarball. So a lot of third-party libraries will have their own build process based on tools like AutoConf or CMake. And so for those libraries, we just want to take the whole tarball and just drop it in and do the configure compilation cycle at gem installation time. So the working example I have is called package tarball. We can see that there's a new directory called ports that contains the upstream tarball for libyaml. We use mini-portil to deal with the tarball. This is a gem that takes the tarball of source code, it runs the configure script, it generates the shared object file, and then it configures makefile to do the right thing with it. It's a really fabulous piece of software. So the new bit in the Extconf is this mini-portil block. The code is really busy. I'll break it down into small pieces. We declare where our libyaml tarballs are, so we can download it if it's not cached locally. We can verify the checksum of the tarball. This line will configure the build system, it will compile libyaml, and it will link it into a shared object. And then these two lines will actually configure makefile. The last line is really interesting. One of the advantages of using an AutoConf package is that you can use package config to set all of your compiler and linker flags. And this was a huge time saver for me when I figured out how to do this. When I actually run the Extconf, you'll notice that all of the libyaml stuff happens before the makefile is created. So the compile and link steps in the makefile know where to find the libyaml that was just generated. The good thing about this strategy is it's a known good version of the library. I can rip out all of my edge case handling. Sweet, chef kiss. The bad version is now I'm on the hook for security updates to that library. So you'll notice a lot of Nokigiri updates end up being new version of libxml, security patch, please upgrade. That's just the responsibility I have now, but I still think it's a better user experience, and I'll circle back to that in a little bit. The ugly thing, of course, so good, bad, and the ugly, installation time is really bad. This is now 13 seconds. If you remember, the system installation was about 1.5 seconds, so this is significantly slower. And this is probably a good time for a nice tangent about user satisfaction. Installation time is a really important aspect of user satisfaction. Nokigiri has been named one of the top 5 frustrating gems in the universe more than once. And it's really not hard to understand why when you watch this video of paint drying, of Nokigiri 1.10.10 installing. This is really frustrating. It's been the source of a lot of negative feedback over the years. I'm gonna maybe spare you specific examples, but if you wanna search Twitter for Nokigiri and your favorite 4-letter word, you will have a good time. I'm not even gonna wait for this to finish. It takes 45 seconds, and that's with me using all 8 cores on my laptop. So the next step of Nokigiri's evolution happened to specifically avoid that pain. Precompiled libraries. Nokigiri 1.11, which shipped earlier this year, was the first version that shipped precompiled libraries for most major platforms. So that's me on this machine compiling libraries for Windows, Linux, Mac, and that's ARM and x86. The advantage is then I'm doing all the compilation so that when you install a gem, it's just a quick file copy for you. This gets really complicated though. An amazing tool that helps with this is Rake Compiler Doc. And this is essentially a Docker environment that runs Rake compiler, and I can cross-compile things. So running on my Linux machine, I can cross-compile for Windows and for Macs. It's fantastic. And once you assume that that cross-compilation happens reliably, the remaining problems boil down to figuring out how to package it all and how to test it to make sure that it actually works. So once again, I've got an example gem. This is using package tarball as a base, and there's a couple of extra files here you can see that we use for testing, and I'll circle back on that in a minute or two. But we only make a couple of changes to package tarball to make this work. The first one is the rake extension task, which did look like this before, and now it looks like this. It's a little bit bigger. Let's break it down. Some local variables declare what versions of Ruby and which platforms we care about. And we set an environment variable to let rake compiler know that we're coming. We signal to rake compiler to turn on cross-compiling and create some additional rake tasks. We signal to our Extconf that this is going to be cross-compiling. The Extconf doesn't know unless you tell it that it's cross-compiling, otherwise it'll think it's just doing a native build. And then finally, this block only gets run when you're cross-compiling, and we modify the gem spec. So we remove mini-portil as a dependency because we don't need it anymore, and we remove the tarball because we don't need to ship that to users anymore because we're doing all the pre-compilation. now we have some ugly rig tasks. The first one is run on the Docker host, and all it really does is trampoline into the Docker container and run the bottom rig task. And that's doing all of the work. It's building the extension and it's packaging the gem according to the gem spec that was just modified, right? So top rig task runs the second rig task in the Docker container to do the cross compilation. The only changes we made to the Extconf are to make sure we use the cross-compiling compiler and not the regular compiler. Check that we are in cross-compilation mode so that later on we can flip some flags. So the options we have to set for cross-compiling are, uninterestingly, fpic, which allows us to mix static and shared libraries together. And the second one's really interesting. This is specific to libyaml. Normally, libyaml's build system will run tests. So if I'm in a Docker container and I'm building Mac binaries, I can build those binaries, but I can't run them. And so I can't run any of the tests for libyaml. So I have to turn all those tests off inside the Docker container. One last change we have to make is how the extension gets required. If we look in the directory structure for the package gem, we can see that we have 4 C extensions, one for each minor version of Ruby that we're supporting. So remember that a C extension is specific to an architecture and a version of Ruby. Like this is the version of Ruby part of that. If we're running Ruby 3.0.1, then we need to use the precompiled.so in the 3.0 directory. So to do this, we turn our require in the precompiled. It looked in package tarball it was 1 line, but now in precompiled we have to blow that out to try first. Look for the precompiled version that matches our version of Ruby, and if you can't find it, fall back to what it's going to presume is the version that was compiled during installation. So that's a pretty big set of changes, but it's not hard to understand, and that's all it took for us to change compilation to happen at installation time to happening when I ship the gem. It's also important to note that we still have to ship that vanilla Ruby version of the gem for anybody who's not on a supported platform. Hello, FreeBSD users. Any FreeBSD users? Yeah, okay, cool. So if you actually try this, you can see that it installs in under a second. This is because all it's doing is copying files around, right? It's not actually doing any real work. If you're not on a supported platform like FreeBSD, you're going to essentially fall back to the packaged tarball experience, and it's going to be like 13 seconds for you. So this isn't a perfect strategy. I said earlier, compiled C extensions are specific to version of Ruby, the machine architecture, and the system libraries. This takes care of the first 2. The system libraries, there's actually a really big problem here with GNU libc versus Musel libc, which is Alpine. These are not compatible, and a lot of the time we run into problems. If you've ever gotten annoyed at the SAS gem for not being precompiled anymore, this is what broke it, right? The SAS library does not work on Alpine, and so they just stopped shipping the precompiled versions. The mitigation for this, though, is to test all of the time. The Git repo that I mentioned before for the RCE gems comes with demo pipelines that will actually use the scripts I mentioned earlier to build the gems and then try to install them on the target platforms and actually verify that all the tests pass. So we're actually doing that round trip to make sure that the precompiled gems really do work. Unfortunately, this doesn't cover Musel today because the GitHub actions don't work on Alpine. So if anybody here works for GitHub, please fix that. That would be wonderful. So most gems should not do this. During last year's Ruby Kaigi, Sutu Kuhei, who's the maintainer of Rate Compiler, gave a talk entitled Goodbye Fat Gems, where he encouraged everybody to stop doing this. He made a lot of really good points in here. Some are still valid and some are not. One is that users can't use the latest Ruby. This has been fixed. Like Bundler lets you use a more modern Ruby, and it'll just compile the vanilla Ruby version instead of trying to install a precompiled version that doesn't work. Upstream patches to third-party libraries get delayed. That's on me as the maintainer. I'm willing to accept that. Users can't control the version of the library they use. As the maintainer, I'm going to go ahead and say I know better than you what version of libxml you should be using, and I hope you trust me on that. High maintenance cost. It is a high maintenance cost, but it's a one-time cost to set up all the testing and the configuration, and that's cheaper for me than doing all the user support. I'll talk about that in a minute too. And finally, optimizations aren't enabled for specific platforms, and this is actually a really good point. Some GCC will do some really amazing optimizations for specific architectures, and you're not going to get any of that with the precompiled version of Nokigiri. But here's why it's a good thing that we precompile Nokigiri. For me, it's a good thing because there are fewer support issues. I've gone from 1 a week to like 1 a month. Dropped by a factor of 4, pretty good. It's a good thing for you because you're struggling less as a user. The page hits on the installation docs are down 30%, while page hits on the rest of the nokigiri.org site are up 20%. So people are struggling a lot less. Fewer angry complaints. If you do that Twitter search for the 4-letter words, they basically drop to 0, except for people who are still on older versions. For the universe, it's a good thing because, well, Nokigiri is web scale now. Since January, precompiled versions of Nokigiri have been downloaded 60 million times. It's a really big number. If you do back of the envelope power calculations, assuming some things about your core, 2.75 megawatts over 10 months have been saved. This actually isn't that much. If you know, it's like a refrigerator running for 9 months. That's what we saved. Or like half of my plane flight here was covered. Anyway. I thought it would be more, but we'll keep going. There's a back of the envelope time calculation we can do too, which is that if you take 82 seconds, which is the installation time if you're using one core, and you multiply that by 60 million, even if only 10% of that are humans waiting for the build to finish, that's still $13 million. That's like a nice gift to Ruby companies, I guess. I feel pretty good about that. Right, so it's a good thing. I'm running low on time, so I'm just going to rip through this, but I don't feel bad about having a second refrigerator anymore, y'all. It's good. Quick word about trust before I wrap up. How do you know what's in the box? Precompiled gems, like Nokigiri, are giving you an opaque library file that's just copied onto your production system during installation. Like, how do you know what's in it? The short version is you don't. You don't know what's in it. You could like decompile it and analyze it if you wanted to, but like human tools make it look like this. There's no way you as a human can eyeball it without specialized tools. And the question about whether you trust that gem boils down to, do you trust the source, the author, and do you trust the chain of custody, the system that delivered the gem to you? Why do you trust this guy? You don't know if I follow basic security hygiene. I mean, I do. You don't know if I'm liable to be blackmailed. Am I doing anything fishy on the side? Do I have illegal gambling debts? Like, you don't know if somebody's going to try to make me inject something into your supply chain. Thankfully, I'm a good guy. Don't worry about it. Trusting the supply chain, though, like, have all of the maintainers enabled MFA? Was the gem signed? Did you check the signature? Have you checked your checksums? For Nokigiri, we do what we can to make all that information available to you, but I'm betting that most of you never check any of those things. I started a discussion asking people what would help you trust Nokigiri more, and I got 3 comments. One of them was from Aaron, which doesn't count. Sorry, Aaron. Anyway, I think you're all too trusting, and I want you to be a little bit more paranoid. Specific things that you could do. If you are a gem author, enable MFA on your account on Ruby Gems. A new feature that just got released last week is that a gem can opt into requiring MFA for all future versions, and Nokigiri's opted into that. Gem signing. My team at Shopify is working to improve existing gem signing along with the rubygems.org team. But we have a proof of concept that integrates it with Sigstore using kind of modern signature technology. So if you find me, I will talk to you about this until your ears bleed, and I will introduce you to my team. So if you're interested in this topic at all, please come find me. Real quick, I have 10 seconds left. Coming soon. Rate Compiler Doc will support ARM64 Linux this winter. If you're using Graviton on AWS, this is important. We're going to refactor Recompiler Doc to be easier to use in a CI/CD pipeline. Hopefully we'll ship 3.1 support early this year, maybe. Hi, Lars. This is going to be on you. And I want to work harder on this Musel versus glibc compatibility, because this is really a big problem. And if we can get all of the precompiled gems working on both sets of libraries, both Alpine and regular GNU Linux, that would be really great for the ecosystem. Big thank you to Lars, Luis, and Kuhei. And we have 50, well, I'm over. The clock is counting up now. Anyway, that's my talk. Thank you all for listening to me babble about C extensions. I appreciate it.